Alrighty, everyone. So in this video, we are going to dive into recognizing linear functions. Okay, we just got out of our functions unit. Now we're going to focus solely on linear. Okay, you should remember that the parent function of linear functions is y equals x, or we could call it f of x equals x. So a function is linear if it has a constant rate of change. And what that means is as the x go up by a certain constant, the outputs, the y values, are also changing by a certain constant. All right, so like these x's from 2 to 3, I add 1, 3 to 4, I'm going up by 1, 4 to 5, up by 1, 5 to 6, up by 1, 6 to 7, up by 1, 7 to 8, up by 1. Okay, so my input values, my independent variable, my x coordinates are going up by 1. Okay, what about my y coordinates? 8 to 5, I'm going down by 3. 5 to 2, I'm going down by 3. 2 to negative 1, down by 3. Negative 1 to negative 4, down by 3. So on and so forth. Okay, this entire table, and I need to check the entire table. All right, the entire table, the output values, your dependent variable, your f of x, or your y coordinates, remember this is just a fancy way of saying y, okay, go down by 3. All right, so rate of change, the rate of change here is the change in y over the change in x. So y is going down 3 for every time the x goes up 1. Okay, so the rate of change here is negative 3. Every time the x goes up by 1, the y is going down by 3. Okay, another word for rate of change, which we'll get into later on in this unit, is called slope. Okay, so that's the slope of the line. That's going to be a big buzzword that we're going to use this unit. Okay, linear functions can be written in the form of y equals mx plus b, or f of x equals mx plus b. Okay? The m represents the slope, or the change in y, which we could write using the math symbol delta. Okay, change in y over change in x. Okay, that triangle symbol is delta, which means change in. The change of y over the change of x. Okay? All right, and the b value represents the y-intercept. Okay? Remember, for an intercept, if it's the y-intercept, the x-coordinate is 0, the y-coordinate is b. Okay? So that is what this equation is. This is called slope-intercept form, and we're going to get into it more in later lessons. Okay, but right now, we just need to delve into, are we dealing with a linear function? All right, so in example 1, let's determine if the equation's linear. Okay, let's see, can we write it in the form of y equals mx plus b? Okay, so for g of x, I can rewrite this, I can rearrange this to be negative 2x plus 4/3. All right, my rate of change is constant, negative 2. Okay, every time the x values go up by 1, the y values go down by 2. So yes, this is linear because you can write it as y equals mx plus b. You can write it like that. Okay, what about in b? Well, in b, a red flag should be this exponent of 2. Notice how the x-coordinate does not have an exponent when I'm dealing with a linear function. All right, so this is a quadratic. So no, this is not linear because it's a quadratic function, which we'll get into in the future. All right, what about C? Well, C, can I write this in slope-intercept form? Well, yes, there's a 1 in front of that x, so I can write 1/9 x plus 1. My slope, my rate of change, is a constant value at 1/9. Okay, so that is a linear function. All right, let's determine, in this example, let's determine if the table represents a linear function. All right, so what are my x's going up by? My x here is going up by 2. From 5 to 7, it's going up by 2. But from 7 to 11, it's going up by 4. Okay, so it's important to note how your x values are changing. What about your y values? From 15 to 10, that's going down by 5. From 10 to 5, it's going down by 5. From 5 to -5, it's going down by 10. Okay, so what are these rates of change? Remember, it's the change in y over the change in x. Okay, so this first rate of change is -5 over 2. Okay, the second rate of change is -5 over 2. This third rate of change is -10 over 4, which if I simplify that fraction is -5 over 2. So you'll notice all of these rates of changes are the same. So this entire table has a constant rate of change. Okay, even though for the last two columns we jumped 4 from 7 to 11, we could say 7 to 9 and 5 would go to 0. Okay, we could fill that into the chart. So is this a linear function? Yes, it has a constant rate of change. And that constant rate of change, which is the m, is -5/2. Okay, that's the constant rate of change. When your x's go up by 2, your y's go down by 5. Okay? What about in B? What about in B? So 2 to 4 plus 2, 4 to 6 plus 2, 6 to 20 plus 14. Okay? And then -4 to 0, we add 4. 0 to 4, we add 4. 4 to 8, we add 4. Okay, so my rates of change are 4 over 2, which is 2. This one is 4 over 2, which is 2. This one is 4 over 14, which is 2 over 7. Okay, so is this a linear function? No, because this rate of change does not match the other ones. Okay, so no, it does not have a constant rate of change. Constant meaning that it's the same for every change in y over change in x. All right, so 2 equals 2, but that does not equal 2/7. Okay, it's not constant for every move that I make in this table. So this is not a linear function. Okay, in the next video, we are going to do the same thing, except for now, we're going to take it a step further and be able to write the equation that's represented in the table.